in your project class file. Okay, so for that, what we'll have is, if I show you this, so let me open this. I showed you the Eclipse last time, no, right? I showed you the Eclipse last time. I explained you only the project structure, right? But I showed you the Eclipse. No, no, right? Okay, fine. Okay, fine. That's what I got out actually. Okay. So I'll be using Eclipse latest version. Eclipse latest version 2022. That is the latest version. And how I'll get the latest version is I'll share you the link one minute. Eclipse Java EE download. If I go here, okay, a newer package is available here. Click on this. Then you can see Eclipse IDE for Java, Enterprise Java, and Web Developers. Okay, Eclipse IDE for Java developers. Okay, so just click on this. So if I go to Windows, just select this and copy link address. I'll share you this so that you can download all these actually. Okay, this is I sent you everyone this one. You just download the zip folder. You just download the zip folder. Okay. So now, so once for me already it is downloaded. Okay, so what I'll do is, I just give a workspace. I'll just put, so DevSecOps third batch. So DevSecOps third batch. So I'll give this workspace. It is getting created. Yeah, if you already Eclipse in laptop, no, it is for the first time. I'm telling those who want to download first time. First time. So this is your workspace, and in this workspace you can create any number of projects. Okay, all our projects are Maven projects. So click on this Maven project, create a Maven project. You see here. I'll go a bit slow here. Okay, so Maven project. Maven is itself is a separate tool for us, which is the third tool in our course. Okay, that's why I'll not go in depth of Maven, but for now, I'll just tell you how to create a Maven project for our JUnit, for our unit testing code. Okay, so just use default works location. Just select this. Next, click on next. Okay, click on next. Then select internal, catalog internal. Okay, just see, select catalog internal. You will get archetype quickstart. Okay, for now, what is this all that forget? I'll explain when I explain you Maven 2. For now, I'm just creating a project where that Maven project will generate a folder structure like this. We'll create a folder structure like this. Okay. Now, just I select quick start. Okay, quick start is for standalone projects. If I want to develop web applications, I will select web app, which I'll be showing. Okay, actually now we don't need now, because when I explain actually kind of this Spring MVC and all that, there we need this web app. For now web applications we are not going to develop. So I'll be just telling this quick start. So what is this mean? This is a template. This is a template. So when we select this template, Maven will create a project structure for us. So when we select this template, so Maven will generate a project structure like this. Okay. Now just select this, click on next. Okay. For now, forget about what is group ID, artifact ID, package. Forget about that. I will tell you when I explain you about Maven. So for now, I'll just give the group ID as JUnit demo 1. Artifact is also the same thing. Next package is com.junit demo 1. Okay, this is nothing but the project name actually. Okay. Next, click on finish. That's all you see. So Maven, what it is doing, it is creating a project structure for you. In the left hand side, if you see, it is creating a project structure. Now, if I expand this, see, I got under source main, under main Java. See the same structure here also, right? Under source, this is a project. Project is JUnit demo 1. This is a project. Okay, if I compare this, if I compare this, okay, if I compare this under source main Java, the same. If yesterday also I told you, right? Source main Java, under source, under main, under Java. Okay, here I'll have all the, this is a folder path. Under this, I will have the, under this, we can create package structure where we can create Java files that have business logic. See, Maven is creating the structure for this files. Now we have SRC test Java. So under this we can create package structure where we can create test Java files. I mean test code. That is unit test code. Okay, unit test code. So these are the Java files which has business logic, and these are the Java files which has unit test code that test this business logic, right? Then fine. And here you have pom.xml. Okay, this is your project structure. So this is your project structure. Created by Maven. Okay. So I told you, right, in the last session, Maven, we can create a default Java project structure. Okay. This is what I told in the last session. Not only that, I mean, there are some more users, but for now, these two mainly. There are some more users, like the main purpose is Maven packages the project, everything. Okay. Maven will create a Java developer structure. But for now, we'll take the first point and second point, okay, for our JUnit examples. Okay, so Maven will create a default Java project structure. Next, Maven will download third-party libraries required for the project and adding the class file. So for that, if you see this pom.xml, so this is actually the main component of Maven project. And pom.xml is generated by Maven only, right? Main component of Maven project. And how we got this Maven project? First of all, how we got this structure? I showed you, right? So go to File, New, Maven project, click on Next. Okay, select this template, Maven archetype quick start. Okay, so select Maven archetype quick start. So this is the Maven project template to develop Maven project that creates standalone Java projects. Okay, project structure. What is a standalone which is not related to web application? Not related to web application. Okay, so I selected this template. And this template has created project structure like this. Okay, so this template has created a project structure like this. Okay, so just select this, click on next. Next, give group ID. I'll tell you what is this when I explain you Maven. I'm not going to spend time now actually, because Maven tool is a separate tool. But for now, you can think like, give the project name, whatever the project name you want to give in all the 3 sections. 1, 2. And package is your Java package. The package, whatever you give the Java package. If you see here, see Maven has generated a package, see com.junitdemo. This is one which I have given in the package. Under source main Java, com.junitdemo, this is the package. And under this package, see Maven has generated an app.java program, so which is an hello world program. So this program we did not written, Maven has generated for us. Now we can create as many Java files under this package, or we can create new packages, but we got a basic project structure now. Okay. And now under source test Java, you see, there is again, this is the business class, and this is the unit test code, which is actually using JUnit actually. Okay. And this test code is also generated by Maven, but we are not going to use this test code. We are going to write our own test code. This is the default test code generated by Maven. See, Maven has generated the project structure and 2 sample files for us actually. Okay. So now, I'll click on this, just I'll select 14. Okay. Okay. So, and now you see here. And my JRE system library is J2SC 1.5. By default, Maven template is creating with 1.5 version, but in our programs, we are going to use 1.8 actually. Okay, JDK 1.8 or even JDK 17 also you can use. Okay. So for that, what I do is, I'll tell you, for now, artifact ID means think like it is a project name, that's all, your project name, your Java project name. The project name is JUnitDemo, right? That is your artifact. I'll tell you what is artifact ID, group ID when I tell you Maven, but not now. Maven is a separate tool. This is just to show you the JUnitDemo I'm telling you, okay? Okay then. So, artifact is your project ID, project name, okay? Now this 1.5 I have to change to 1.8. For that, what I do is go to this project, just see, go to this project, right click on this and go to your properties. Now I'm changing the JDK version, not from 1.5, I have to use 1.8. Then go to the Java build path. Okay, again I'm telling you. So right click on this, select the properties. Next, select Java build path. Select Java build path. Select libraries. In this, I have J2 system 1.5, but you have to remove this and put 1.8. So select this. So select remove. Now I should have JDK 1.8 or JDK 17 installed in my system. Yes, it is already installed. So I'll select the add library. Again, you see, again, I'm telling you once again, right click on the properties. Next, select Java build path, select libraries. Just select this and remove this. J2 is 1.5. I have to add 1.8. So select add library, select JRE system library, select next, select next. See, select JRE system library, select next. Now don't use this workspace default. Select alternate JREs, select installed JREs, and now you have to click on add where you have to select your JDK 1.8 installation path in your Windows system. Okay, select add. Now click on standard VM. Click on standard VM. Click on next. Click on next. Okay. Now select the directory. Okay. Now select the directory. Now select JDK 1.8 pin. In this path I have installed. Okay. In this path I have installed JDK 1.8 pin. Okay. Select folder. Now click on finish. Okay, sorry, not this one. I should go back actually. JDK 1.8. Here I should not pin. Okay, sorry. I'll remove again here. No click. Okay, sorry. See, add library, JRE system library, install JREs, add standard VM, directory, go to your JDK 1.8. So this is your JDK 1.8. Click on finish. Now select this, click on apply, apply and close. Now your workspace default JRE has become JDK 1.8. Select this, click on finish. Okay. Now you have to change the Java compiler also. Change from 1.5 to 1.8, your Eclipse. Now apply, yes, apply and close. Now your JRE system library has changed to 1.8. Okay. See, again, I'm selecting you. See, right click on properties once again. Go to your Java build path. Okay. Okay, suppose it is 1.5. Okay, I'm just telling you again. Again, I'm removing it. Again, I'm adding. Add library. Just see. I'm just going a bit slow. Add library. Okay. Add library. Once again, I'm writing again to everyone. See, right click on this. First, right click on this. Just note down. Right click on the project. 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 Now select properties. Select properties. Go to Java build path. Okay. Go to select Java build path here. Okay, I'll remove this. Okay, for now I'll add again. So now select add, click on add library. This part. See my mouse where it is moving. Okay, see my mouse, it is going. Yeah. Okay. See my mouse where it is going. Okay. Add library. Now select JRE system library. Select JRE system library. Next, click on next. Click on next. Okay. Suppose assume that here it is 1.5. I want to install JD. I want to set JDK 1.8. Now select alternate JRE. Select alternate JRE. Now click on installed JREs. Now click on installed JREs. Now click on install JREs. Now click on add. Now click on add. Now select standard VM. Select standard VM, click on next. Now give the JRE home. Where is your JDK 1.8 installed? Go to the directory. This is your JDK 1.8 in your Windows system. Okay, select that. Select that. You will have all these jars coming. Okay, already I have selected, so that's why it's already in user registering. So once you get finish here, okay, now it is disabled because I already added just now. Okay, so this will be added here. Now select this JDK 1.8. Okay, which is your JDK 1.8. Now select this JDK 1.8. So your workspace will become JDK 1.8. Click on finish. Now go to Java compiler and select 1.8. Okay. I think I cannot go beyond this slow because this is very, basic of setting Eclipse actually. I'm very slow actually. I think beyond this I cannot go actually. But again, I'm telling you, again, I'm repeating. Okay. So right click on this properties. Okay. Now select Java build path. Select Java build path. Okay. For now, I'll remove this. Okay. I'll add again. Select add library. Select JRE system library. Select next. Okay. Select alternate JREs. Now already 1.8 is there because now only I set up. But if there is no 1.8, select alternate JRE. Select installed JREs. Click on add. Select standard VM. Select JRE home where your Java is installed. JDK 1.8 installed. Now click on this. Select your Windows path. So this is 1.8 and click on finish. That's all. That's all. And then you change the Java compiler to 1.8. Okay. That's all. Now you see here, I think JDK 1.8 is not there. Okay. So JDK 1.8 is showing, you see here. Fine. Now, all right. This is my Maven project with JDK 1.8. Now, if you see this JUnit, this is a old library. Now we are going to use the latest JUnit. We are not going to use this, okay? In pom.xml, if you see, I'll explain you what are these dependencies and all that later, okay? But for now, what is pom.xml means? So this is the main component of Maven project. And here we can specify what libraries to be downloaded, what third-party libraries to be downloaded to Maven project, to project class path. We can specify what third-party libraries to be downloaded to project class path. Okay. Now, if you see here, JUnit, this is the dependency. Okay. I'll tell you what is dependency and all that. But now you can think like the third-party libraries that we need to download will put in dependency section. Okay. So the third-party libraries to be downloaded can be put in dependency section. In pom.xml. The third-party libraries to be downloaded can be put in dependency section in POM. And again, for your information, I'm telling, Maven is a separate tool in our course where I'm going to tell you each and every part of the component. But for now, this is for JUnit. I'm trying to tell you, that's all. Okay. Now, this is created already by your Maven template where I got. Now, if you see JUnit version 3.8.1, but now the latest version of JUnit library, it is 5 now. We are not going to use this version. We are not going to use this version. Okay. So we are going to use a different version. Okay, which is the latest version. This is the old version. This is the old version. Okay. So we are going to use the latest. We are going to use the latest version. So what I'm going to do is, so right click on this, edit, right click on. Okay, just what I'll do is, so instead of JUnit, what I'll do is org. This is the latest version. JUnit dot Jupyter. So if you want to actually know that in Google also, you can go to Google. Say JUnit Maven dependency. Just search for that. Okay, you have JUnit 5. Put JUnit 5 actually. JUnit 5 is the latest version. Okay, go here. Okay, go here. And if you see, this is the latest version, 5.4 or 5.7 also is latest version. You can go here. So what I do is org.junit.jupyter, JUnit -Jupyter. And the version is 5.7.0. Version is 5.7.0. This is this is your JUnit library. Okay, this is the latest JUnit library. Now, if I add in dependency section, just see the power of magic, magic of Maven, what it is doing. Just I save this actually. I save this. Now you see this library is downloaded to your project. You see, if you see here Maven dependency, all these jars are downloaded automatically. And how it is happening, I'll tell you when I explain you Maven course. I'll explain you when I explain you Maven course. But just if I add this dependency, all these jars are added to your project. Imagine that if you don't have Maven, you have to download each jar and put in your project. But now, just you add this dependency, so Maven has downloaded all these dependencies from the internet. And how it is downloading all that, what is happening behind the screens, I'll tell you when I explain you Maven. Now, for now, these jars are added to your project list. Now, what is there in these jars? These jars has libraries where I can write JUnit code actually. These jars are having pre-built classes, Java classes, where I can write the JUnit code happily. Okay. Now, that's all. This is about Maven. Now, forget about Maven. Maven we'll see only when I explain you Maven tools. But now, don't think about Maven. Now, concentrate on the JUnit. Okay. Now, come to your app.java. Okay. So now let me write now some business classes. So let me write now one simple class here. Here I have one business method, public int sum of int x comma int y. Okay, just I'll say return x plus y. Okay, this is a business method. Okay, this is a business method that that adds two numbers and return the result. Okay. Now, so okay, forget about Maven now. Forget about Maven. Okay, now Maven has downloaded all my JUnit libraries. That's all. Forget about Maven. I'll tell you when I explain you Maven 2. Okay, for now, focus on JUnit 2. Now I got required JUnit jars. Okay, now I can start writing programs. Now this is your business method. Now I need to write the test code for this method. unit test code. That means I need to test this method. If you remember, what are the test steps? So I pass input, I define expected output. Now I create an object, I call the actual output. If expected output matches, then the test. So this logic I'm going to write in JUnit. Okay. Now where I'm writing JUnit code in apptest.java. This is your business logic. Now in my apptest.java, right now you see I removed the old version. Now it is showing error. So we are not going to use this one. So let me remove all this part. Okay. Now what I'll do is I just say class apptest. Okay. And here I write one test method. Okay, one test method. So where, if you see here, so this is an annotation. This is an annotation. Okay, in Java we call this as an annotation. When you study full stack Java, you'll be studying these annotations. So this indicates. So this indicates the method is a test method. Is a test method that is executed by JUnit library. And where I put the method here on it, public void test sum. If you see here, this test is a part of org JUnit Jupyter API test package. And from where this class is coming? And this class is coming from this dependency, and this dependency is having these jars. So in these jars, okay, in one of these jars, this class is present. Okay. Now in this test method, I'll simulate this logic. First, I'll define the input. So let me define the input. So int x equal to 10. Whatever I've written in the English statement, now I'm converting this to Java. Next, int y equal to 30. Next, now I have to create an object here. Now object is not the class name I have to give. I have to now call the actual method, right? First, I'll create an object here. App is equal to new app. Okay. Next. Okay, expected output also I have to define, right? So int expected output. See, first x input. Next, second step is expected output. So I know that if I pass 10 and 30, expected output will be 40. It will sum. Okay. Now I have to get the actual output. So app new app. Now I'll say int actual output. Okay, I have to get the actual output, right? Int actual output is equal to app dot sum of x comma y. Okay. Now you see. Now expected output and actual output. Expected output I am defining, and actual output I am calling from this object. Okay. Now JUnit. Okay, JUnit has a facility where we can compare expected output and actual. We don't need to write if-else conditions. See, generally how we do, if expected output equal to actual output, then I'll say test case is possible. Instead of writing like this, instead of writing if-else, JUnit has provided a very simple way. So that is called asset equals expected output comma actual output. So asset equals expected output comma actual output. Now you see asset equals is part of your JUnit package, and what this does. So asset is nothing but asset equals is nothing but asset equals what it does is asset equals is a part of JUnit library. And what this does is asset equals will match expected output and actual output, and if both are equal, then JUnit makes this test as pass. Otherwise, JUnit will make test as fail. See, instead of writing if else conditions and everything, just with a simple asset equals. Okay, like that we have so many assets. Okay, these are assertions. So asset equals means asset equals will match expected output and actual output. Okay, and if both are equal, then JUnit makes this test as pass. Otherwise, JUnit will make test as fail. Now let us run this. Okay, let us run this. How do you do is just right click on this, run as, select JUnit test. Select JUnit test. You see now. Now you see, I got a green color here. If I got a green color here, means the test is passed. And here you see you can see at the bottom there is a green symbol here, test sum. That means the test is passed, correct, right? Now I'm passing 10 and 30, expected output is 40. Even if I call sum method also, if I pass 10 and 30, so return 10 plus 30, 40. Your actual output is also 40. Your actual output is also 40 and your expected output is also 40. So both are equal. Suppose my expected output is 40, but I write some error in the business logic. Sometimes mistakenly, instead of plus, I write into. Now let me run. Now unit test will catch this. You see, just run as JUnit test. Now you see, I got a red color. You see, expected was 40, but was 300. Your actual was 300. The logic of the method is 300. The logic of the execution of method is 300, but your expected result is 40. Right? Why means then you'll go and see why my actual is 300. If my expected is 40, then you'll go and see the logic. Okay, I will see if I pass 10 and 30, it is multiplying, not adding. So 10 into 30, 300 is coming. Okay, I did some mistake in the logic. So again, I'll correct it. So in this way, though programmer makes mistake, your unit test will catch where is the mistake. So that is the advantage of this. So and why you got this fail? Because what asset test will do? Asset equals will match expected output, actual output, but your expected output is 40, your actual output is 300. So it will make JUnit test as fail. That's why you got this red color and you got a failure message. So asset equals will make you fail when both are not matching. So that is the beauty of this JUnit. That means though programmer makes a mistake, in unit testing you can find that mistake where I have done. Now again I correct this mistake and again I run this. Now run as JUnit test. Now you got the test case passed. So you got the test case. There is no error. If you got a green color means there is no error. If you got a red color means the error. Okay. So that is the actually beauty of unit. So though programmer makes mistake, okay, your unit test has caught that. So that is the advantage of unit testing. Unit testing means you are testing each and every method, whether the expected result of that method is matching with the actual output of the method. Okay. Any doubts till now? Clear? Yeah, that is very good question. See, now small numbers, you are very good question. Like now small numbers, you know the expected result. Even in the larger programs also, I'll be telling you that also. See, first I'll start with small numbers, then I'll go with the larger. Even in larger numbers also, based on the requirements, you only developed that code, right? You only developed that code. So how you developed that code? You might have known that if I pass this, I will get this output. Based on that only you have written the logic, right? Based on that only you have written the logic. So definitely you can know the expected. Because if you don't know expected means you cannot write logic of that method also. You cannot write logic of that method also. So you know expected definitely. Okay. So that in that way you have to determine expected. Okay. Now we'll see one real-time example also tomorrow. So tomorrow we'll see real-time example also. So now I'm starting with a simple examples. Okay. Yeah, we can write multiple test cases also. I'll show you those things also. Okay. Okay. So this is the program. Okay. So tomorrow we'll continue actually because the thing is I'm going a bit slow. That's all. Okay. I'm going a bit slow. So that's why tomorrow I'll continue further. I'll continue tomorrow further with some more examples. So just I wanted to introduce, I wanted to bring you the flavor of JUnit. Now you got that flavor. Now tomorrow we are going to see multiple examples. Okay, multiple examples with some real-time example, everything. Okay. See, as I told you, pom.xml, just forget about this. I'll tell you what is this pom.xml, dependencies and all. As of now, you can think like, if I add a dependency here, Mammon will download the required libraries to my project class path. Now I got the libraries, that's all. Now forget about that. Now I got all the JUnit libraries. Now I'm using the classes. I'm using the classes from that libraries, I'm importing the packages from those libraries. But Maven is a separate third tool we are going to see. In our course, if you see, okay, in our course, if you see, so Maven is a separate tool we are going to see, okay? After completing JUnit and Mockit, I'm going to explain you Maven. There we'll go in depth of Maven. Okay? I'll go a bit slow. Okay, now I'll stop the session. Any doubts you can ask me. Oh, Google Classroom link, right? Sorry. Today okay. Tomorrow morning I'll check with the admin, with our admin, and then I'll get that link and share it to you. Previous videos link, I don't have that. I think I shared to previous videos link that is there in YouTube. I think I'll get the video link. Okay. Okay, I'll upload all these notes and programs in the Google Classroom link. Just wait for tomorrow. I'll share it. Okay then. Okay. So everyone has taken the notes, right? I think I'll share you the screenshots also to everyone. Okay. But always remember, okay, who are attending the class, take a pen and paper, notes, and take the important points that I tell in the class. Okay. Don't listen the class with a relaxation mode. If you listen the class with a relaxation mode, after this class, you'll forget it. Okay then. Okay then. Okay, fine then. Tomorrow I'll continue with 8:30. So tomorrow I'll see. Today I brought you the flavor of JUnit. Tomorrow onwards I'll tell you. Tomorrow I'm not going to explain Maven again because Maven we'll see in the our third tool. But tomorrow I'll start with directly with the JUnit programs. Now you got JUnit one program, right? Now we'll continue more examples on JUnits with the different examples. Today I started with simple sum example, okay? Addition example, but we'll see tomorrow some more examples. All right then. All right then. Thank you all. Okay, see you tomorrow. Thank you all. Okay, take care everyone. Thank you all.